All right. So boys, so I'm Harooks or Harooks, however you want to pronounce it. I've been developing in Solady for I don't know, like a year and a half now. Um, but pretty much uh the main contributions and like development, I work for so Bell Finance. Okay, I can pull it. So we do uh synthetic tokens, like sort of similar to Compound. It's a fork of a couple different projects, but uh, we just cover like synthetic assets, stuff like that. So I'm on the team for just like smart contract development and then like handling like Immunify reports, as well as some front end. And then I'm also with the Blueberry Finance team. We just launched not long ago. Loon Finance, which is sort of like a subsection under, and I help them sort of like with their contracts and doing like code reviews. Um, but yeah, those are the two main ones that I'm contributing to actively, and then I also work with one of my friends, Coffee and Weed, and that's his name, but we have a like smart contract review company, or not really company, but really group, Korok. And that's where we sort of handle our independent code reviews. And then, yeah, 3 crits and 4 highs. That's just this year. Out of Unify, I need to spend some more time, but
Very sexy background, and Ball Finance is quite famous. So congratulations on getting a job.
yeah, thank you. Yeah, so so we'll talk about just sort of one of my main focuses is sort of transitioning towards like gas optimizations, obviously, and I know that's something that's growing super quickly. But yeah, why optimize? Basically, you guys may know Vectorized or Harrison on Twitter. They make like insane loads of money just optimizing. Like they'll charge. I've asked them before. They charge like tens of thousands just for just like small reviews. Like these guys, they milk it. Like once you get good at optimizing, so profitable. Like it's crazy.
But they're the best, right? Like they're literally 1 and 2, like literally.
Yeah, yeah. It's kind of hard. Things like the few sort of like drown in the work, and then the rest of us sort of like trying to like milk the udder, you know. But there's still a lot. Yeah, it's still very profitable, and there's still a lot of opportunities for people who focus on gas optimizations, because there's still so many there's so many easy pickings. Like in Code Arena, I know that the pool for gas optimizations has been reduced, but just there's so many like easy fixes that you could just do gas optimizations and do extremely well just with solo code reviews and stuff like that. But yeah, only the select few take the time out to go deep in the rabbit hole. Just like if you learn Yule and sort of just like focus up, it's super profitable, and it's really interesting too. So one of the first things that I see sort of like on Code Arena and Sherlock and in solo code reviews is just like insanely large libraries. Like sometimes people will use like, let's say for example, like you use the safe math library, right? And you only use like 1 or 2 of the functions. There's just so much bloat that during deployment time, it's pretty much like unacceptable. So just making sure you import just the certain functions that you need, especially in like tool-based libraries, that's just like extremely important and something that a lot of people brush over when they're just trying to like optimize the code that they see rather than like what can we actually get rid of. And then one of the biggest ones as well is trying to optimize like I see like the like 60% of optimizations that I see that make like a ton of money on Code Arena and Sherlock, whatever, is it's all just like based in loops. Because loops, like if you look at it just from a distance, it may look optimized, but a lot of times you'll see events being thrown in loops, which is extremely like unoptimized. And then like I'm still surprised that I still see people just using I++ when most of the operations are going to be unchecked. And then as well as hashing storage variables. So like if you're accessing an array, like a length of an array, doing this right here, doing the array.length, every single time it goes through the loop, you're doing an sload. It's just extremely inefficient and you need to be caching all stored variables. Yeah. And then another obvious moneymaker is like storage optimization. Like the number one like gas sink is sload. Sload is like, it should be like your number one enemy. Trying to make everything just mloads and reading from call data. It's just extremely important.
I just gotta say this, bro. Amazing talk.
Oh, thank you.
Thank you so much.
Yeah. And then, yeah, so you want to stack pretty much every single struct. Use as little storage slots as possible, because every time you're using that struct, you're accessing that, and it's just structs carry so much inefficiencies that that's something that you really need to focus on, because that's where a lot of the gas sink is going to be. And then another thing is constants and immutables, because they're stored differently and it's actually stored in the code. You're not using sloads or mloads. You're just reading from the code. So it's going to be a lot cheaper. And if you're accessing these variables in loops, it's just going to be really cheap. And then as well as one of the things with structs is I see a lot of people using the delete keyword. So like if it's an array of struct, say it's like a user struct, it has a lot of data regarding like the user balance and whatever specific to like user information. Every time you delete, it has to reset every single piece of that struct. So like user balance, friends, whatever. Yeah, there's an operation for every single one of the variables in the struct. So that needs.
I never knew that. So there's an operation for each one of the parameters in the struct?
Yeah. So it has to reset every single one.
Wow.
Yeah. So about a year back, September 2022, in the year, I wrote an article on sort of like the dangers. Here, I can link it in chat. Is it the? Oh yeah, here it is. So I sort of covered because along with the gas optimizations themselves, there's like a lot of dangers that it carries, because like when you're writing UL and assembly, it's not all good. Like it's obviously, if that was the safest option, then that's what everybody would be writing with. but there's a lot of things that you still need to be aware of.
But I have a question here. You shouldn't be right. Like, okay, there's a trade-off from readability to optimization. You shouldn't be optimizing super complex code, right? I mean, your assembly blocks should be ideally small, right?
Yeah, for sure. Like this is Solady. This is their this is the ERC20 token. Like, oh yeah. But like this is great, like for just a basic transfer function, but this is like, it's just not readable. We know what a transfer function does, but if this was to be yourself for a protocol, this level of assembly is, yeah, I agree with you. Yes, it is efficient, but there are some trade-offs because this is not readable pretty much at all for like 99% of people. So yeah. But yeah, I was going to cover one thing in here. Yeah, and then another thing, obviously I don't want to see people still reverting with strings. Like, please, in Solidity 0.8, just make custom errors. There's a lot of libraries to help you out with that. But yeah, this is basically the equivalent of each.
So, if the custom errors, they get compiled, so they get prefixed in the code at compile time, and then we have to do a lot of operations for the revert with the string?
Yeah. So it sort of has to convert it to bytes and then store it and then throw it. Whereas with an error, you're just accessing the error and then reverting. So this is 3 operations less. So if this is something that's going to be thrown every single time there's like a major functionality in the code, like, just stop throwing strings. Like, I see a lot of people like there is like there's certain syntaxes that protocols use, but it's just not, it's just there. Yeah, and then optimizing loops, that that's just one of the biggest sinks ever. It's just crazy. And limiting scope of functions, because there is a slight preference towards internal and private. Just keep everything as private as possible. All right, let's see. This is in Seaport. This is just like a basic introduction sort of to Yule, but this is just like, you're just returning the string Seaport, and this is sort of like the equivalent. But I know, like, I don't know if any of you guys did the audit for Seaport, but I believe it was last year, but they have so much assembly that, like, that's such a great resource to learn. And there were a lot of really good findings. I can find.
You know the difference in the gas cost for having the string being returned and just doing the assembly itself?
I know that
I mean, how big it is, at least, like
yeah,
factor?
so I believe just returning the Seaport string, there's 2 more M store. So this one, it's just this, the way that they combine this, it has the length of the string inside of the M store. So you're doing 2 less operations. But yeah, if you're able to convert the string to bytes, it's always going to be cheaper. Like, that's just an operation that sort of like applied during development or during compilation time. So storing, that was another thing that I was going to cover, but when you were storing strings in storage, always make it bytes if possible. I know that compromises readability, but string reads are really expensive.
But there's a question here from LP saying, why not doing it in Huff?
You can. And if you are a developer, then yeah, Huff is great. But if you were looking at it from like a code reviewer standpoint, it's just, you're just going to see more Solidity. I'm actually curious to see if there's been any like, has there been any Code Arena or Sherlock contests written in Huff?
I guess Huff is less used in production, right? I mean, that would be.
I mean, Huff is
Seaport.
Yeah, I'm a Huffer. Like I love
the assembly. Looks exactly like Huff. I mean, just the function selectors, etc. And you can get rid of those to save some. Yeah, but I mean, if the goal is to save gas, I mean, the assembly seems like Huff, right?
Right. No, Huff is a more readable.
Just get rid of the function name and the signatures and just write this in Huff, because I did compare Yule with Huff, and if you write in Yule assembly, it's, I mean, I'm just talking about this code. Maybe if you use Solady and just use Huff, just use Yule in somewhere, that makes sense. But if, I mean, this Seaport Sol, there's only assembly, then you can write this in Huff.
Oh, definitely. But the thing is, like, not as much coming from like a developer standpoint, but more coming at it like a reviewer state. Because like if you're gonna go for like optimizations on like existing code, like if this was, it's just kind of hard to justify Huff in production. Yeah, Z80. Yeah, like Huff is great, and I think making things like really quick in Huff is a lot easier, arguably. But you're just not gonna see it like in existence.
We have Z80 on the stage. Please, Z.
Yeah, so I work in a lot of tooling stuff, compiler stuff, contributed to Viper, work on Ape, which is a Python tooling framework. So I try to keep up to date with just like how are people deploying things, what's the most kind of state of the art production ready type of stuff. And because I also, like many of us, like I'm really like I'm interested in Huff. I think it's super cool. I think it's a really exciting technology. Was, looking into that in mainly from a point of view of like how can ApeWorks support Huff, and what are production Huff developers doing today to get their contracts out there. And the response I got pretty much was like there aren't any. It's pretty much still at the stage where it's like proof of concepts on GitHub that illustrate like where this language is and like the savings that can be had, etc. But it's still just too much of a moving target even, right? Like when you're gonna audit something, like ideally, you want to know like the Viper illustration, the Viper situation illustrated. You want to know like what compiler version was it compiled with, right? Whereas Huff is being actively worked on. Like you might compile today and get some result, and then compile in 2 weeks and get something else just because there's been some improvement or change, and that's a change you have to now be aware of. Yeah, all that to say that it's still early for Huff in those terms. Like it's exciting stuff, but anything securing like actual large amounts of value, like realistically, is not going to be written in Huff. For a while.
Yeah, it's still rolling like super early. Yeah, agreed. You're just not going to see that in production pretty much like at all. Like it's cool in concept, and I think it's bringing people awareness to sort of like what Solidity and Viper are lacking in, but it's just not like, it's just too early. Like Viper was before Solidity, and like it's just not there. Oh, are these people holding their hand up? Is there an error?
Just because this being such a, you know, interactive session, I'm just inviting everybody to speak so we can do questions.
Oh, but.
Okay.
Oh, I thought that was them requesting.
No, it's just me inviting. So just keep on.
Oh,
awesome.
okay.
Thank you.
Okay. Is there an error in the assembly implementation of the name function? No. Do you see an error? Unless I could just be straight up. I can find core.
The return statement.
What's up?
Yeah, the return statement, it's like the offset and the starting parameter for memory read and the offset.
Memory offset? I mean, it does everything properly. Things that I sort of wanted to do was, oh wait, hold on. Make sure this doesn't crash me. I wanted to sort of do, so like if you guys don't know what this Solady, just thank me later. Like if you haven't heard of this, please. It basically, what was it made by? Mudit Gupta? I don't remember. But it basically just compiles all the audits together, and you can sort by gas. So you don't have to look through every single report. But one of the audits that I wanted to sort of take a look at was Nouns DAO, because that was a couple months ago, but there's a lot of really, like, that the team focuses. I know that the pot wasn't that big for gas findings, but there's still a lot of really good optimizations that people made. So but here's, yeah, one got 600. When was this? Yeah, look, first one, what I mentioned earlier, people just import entire libraries. Like when you make a Forge project and you're importing tools from like an OpenZeppelin library, you just don't need everything. Like make your own fork of it and delete the functions you don't need. It's just way too much bloat. Yeah, there's a lot, like whenever you take a look, it's going to be a lot of for loop related things that sort of get the best payouts. Yeah, like I can see this already. Like this is efficient. This could be further optimized. I feel like how this I++ is. Oh wow! I mean, yeah, this is well optimized.
Of what we're analyzing now?
Sure. So, so this could be optimized because it doesn't need to be 256. I believe in older versions of Solidity, I know it's not the case now, but setting it to 0 was less efficient. I don't know why the compiler did that, but whenever you see like UNI semicolon or UNI equals 0, they do the same thing because during compile time, it needs to just set it to 0 anyway. So it's readability purposes. And then like this I'm not sure if this is a storage or memory, but see how this isn't cached? Every single time it's going through this, it's doing sload. So
isn't it a called data? So if it's called data,
call data?
yeah.
Oh, okay. If it's call data, then no. Because you're gonna be the same thing if you're caching. And then this I++ is not necessary. You need to drag this down. Copy this. Okay. So first thing. Okay, let's just say for the sake of argument, state for storage. So first thing, let's say it's under 256. First thing that I'd change, and pretty much always want to take this I++ out and move it down. Here, make it ++i. Oh, I responded to somebody on Twitter recently about between or the difference between ++i and I++.
Which is a meme, by the way.
Yeah, it is. Like you used to actually be able to make like so much from Code Arena just by changing that. Yeah, that was in the golden age. Yeah, it still is there, and there's still a very big difference between the two because essentially with I'll just kind of.
Can you explain the difference? That's actually very interesting. Can you explain the difference between one and another?
Yeah. So I++, basically, in compile time, let's say like variable j, you're storing the initial value first, and then you're saying I plus or equals 1, or make it more complete or more straight away. Do that, and then you're returning the initial value. So when you're doing I++, let's say the original value is, like if you have a uint, 0. So if you do I++ in, let's say you're emitting an event called like counter status, say I++ or counter ++. So if you do this and counter is 0, it's going to throw 0 because it's going to return the initial value and then it's going to add to it. Whereas if you do ++i, all you're doing is saying I equals I plus 1, then you're returning I. So if you did counter ++, you're going to return 0. Do ++ counter, you're going to return 1. So that's another way you wanted to avoid.
So basically, 1 starts with 1 and 1 starts with 0. Is that the right way of think of it?
Yeah. So if you don't care about the return value, then you always want to do ++i. Always. Because obviously this is an operation right here. You're storing it in the stack. That's just not necessary. most of the time. So this is way to abstract it out. So yeah, know your plus pluses. And then the same thing with the minus minus. Yeah. Yeah. Not as common, but
Hope you feel free to open your mic.
but yeah, that's something really important. And be like, where's the so I mean it's a meme, but like, look, this is just like easy pickings right here. And then ERC20 tokens to include. Yeah, see, like, this is another thing that, oh wait, no, never mind, it's memory. Okay, forget it. Then another pattern that I'm sort of seeing, I don't know if it's more efficient or for readability, but I'm seeing a lot of, instead of saying in the loop I is less than token ID's length, people are saying it's not equal to. I don't know the operation or the gas costs associated with that, but keep that in mind that pretty much.
Can you repeat that, please?
Yeah. So, in the loop, some people are saying like I isn't equal to what the loop is going to go to. So like if the length is 1, or no, let's say length is 3, it's going to go through 3 times, and then when the iterator is 3, that's when it'll stop.
That's really weird.
Yeah. I don't know. It's less readable to me, but be aware of that happening. I saw it in, there was some code review. I believe I think it was on Sherlock. It was one of the active ones. And then, let's see. Look, actually, let's see if I can identify any things off the bat. Okay, so this is one thing that can be already optimized. Storing a string, just string literal. This can be bytes.
There's no automation to do that? Do I need to do all these small optimizations myself? There's no slitter or something for that?
No. Yeah, you're compromising readability slightly. Let's see. Let me find. So this is what sort of it's going to look like. And then you can leave like a note above. But yeah, this is what it would look like if you left bytes 32. But yeah, it's all my knowledge. I know that Code Arena runs bots. But take a look, and sometimes that's not always the best option, but want like the best that you possibly can out of it.
I saw some of these platforms, they are not doing, gas audits anymore, but I saw a really interesting counter argument against that, because people usually say that gas audits can go out of fashion because the way Ethereum and Layer 2s tend to be cheaper in the future. At the same time, block space will always remain, at least in the parameters of the EVM chain, the same, meaning that even when the EVM is cheaper, having better optimization could lead in the overall better flow of transactions,
Yeah, agreed. I think everything should just be the quickest, because the native ETH chain, like, we don't know how long it is before we get sharding or like any of these features. Like, it's just having knowledge of these gas optimizations also keeps you aware of vulnerabilities, and when you know these optimizations, you're at like the lowest level you possibly can.
Can you talk a little bit about the standard safety procedures the Solady compiler implements when you have to use uncheck and everything? Because that costs a lot of gas, right?
Yeah. Are you talking about like the like safe math? Like,
yeah, I forgot the specific name. IST. Guys, help me, Z80. What is the that we got default after 08, that we had to use the
oh yeah, I know
I forgot the name.
Yeah, just checking for overflow and underflows, right? Is that what you mean?
Yeah. Not only that, they have a lot. Yes. No, it's not safe method.
User requires to.
It's not safe method. It's the you need to enable the safety in the compiler itself, so you enable all the protections because it's not only overflows. There's other protections. It's IST or something. Give me 1 minute. Just keep on. I'm gonna remember the name here.
Okay. And then another optimization is non-reentrant. Like, okay, this is it's available, but I see a lot of times like people are throwing these, they're putting this modifier on like everything. Like, bro, you do not need non-reentrant for like an admin function. Like, is another optimization you can do. String could be just in custom error. All fair. This is not necessary. You could do this.
Okay, I remember the name now. It's SMTchecker.
SMTchecker?
The default safety stuff we have in the compiler in Solidity.
Oh, right. So you're saying to throw the flags during the compile? Okay. Yeah. But yeah, that's another thing to look at. And then I'm not sure when 0.9 will be releasing, but like knowing every single like latest update, like when 1.8 came out and there was just a lot of changes, people are still using safe math. And like I know that like just us being like aware of Solidity changes and wanting to sort of pay attention to the way that the compiler is moving, we're in the top like 0.5%, because 99% of these people, I'm not saying like oh these are like NPCs or whatever, but like yeah, like most of these people don't know, right? So a lot of these audits that are going to be done, you just need to know these things. Like, just having early knowledge is profitable, even if it's something that's going to be widespread. That's just another thing. Always be up to date on compiler changes, because that's where most of
breaking changes. I mean, you just told us that after 08 something, a lot of things changed. Are those breaking changes?
Yes. Not breaking changes. Actually, were there? I can't remember. Oh, push 0? I mean, yeah. I mean, that's not breaking. But yeah.
Using the right version? Yeah, forget about it. Just keep on, sorry.
Yeah. You're good. But yeah, always be up to date. Just moral of the story. Know what you're writing on. Because when you're writing this code, it's not just like what you're looking at isn't always what you get. And then another further thing, let's take a look. yeah, so proposal count, this is just another small thing that could be done. You can make this inline. It sort of improves readability as well. Or if you don't care about reading the prior value, you do this. Make it nice and clean, put everything in line. Boom. Which actually, that wouldn't be good because you don't want a 0 proposal count. Yeah, keep it like that. Yeah, and then minimizing event throwing, I guess this is for compatibility with Governor Bravo events, but you really should not be throwing 2 events in one. And then this can be optimized. You don't need to read block timestamp twice. Cache that. You guys can read. Okay.
You know, if it's possible for me to let's set a variable outside a contract, like I can do it with events and errors, because I could do that for, let's say, block timestamp, I guess, right? Or okay, that's not useful.
What do you mean?
I mean, you know how I have 3 functions now? You have these functions that are outside the contract, and you can include them.
Right.
Can you do that for variables too? I don't think so, right?
No. You're good. I mean, it's good to gotta think outside the box. All right, back to this. This is really good. Enums are efficient. This is another. Get rid of the string, please. Like, yes, it's sort of readable, but you're doing good here. This proposal, yeah, disgusting. Oh, stored variable, reading the length every single time in the loop. This hurts my heart. First out thing, pass this thing. That proposal dot targets dot length. This is you're doing an escalate every single. Cache this. Much better. Always. Sloads are your number one enemy. Like that is. It's your enemy, but it's also your friend. Is hit a lot. Milk it. Then another thing is a lot of times people reuse stored variables for emitting events. A lot of people forget sometimes that you do have to load the variable to put it in the kind of self-explanatory, but when you're writing it, it just doesn't feel like you're accessing the variable. But
I didn't understand. Do you mean that I should be using memory variables or events?
Yeah, I mean like I know this very well. So like let's say no. Yeah, so they cached. Say this is word variable. whatever. You're also here. Like sometimes what can happen is, yeah, we're doing 2 S loads. We're loading the user balance twice. And a lot of times when you're emitting events, this is another S load. Like, this is just a reason to cache it, if that sort of makes sense. Yeah, so in your mind, when you're reading functions, if you see 2 or more usage of a storage variable and it's not writing to it, that should be like an instant red flag, like a light bulb in your head, like this needs to be cached. Like think of just cache all the time. Straightforward. A lot of this stuff is gonna feel almost monotonous because it's a lot of like stuff. But sort of the way that I work best is if you work best like writing stuff down or like keeping notes on like some note app, just take note of the line and you can always come back to it. But it's kind of hard to change everything at once. Well, coming from a development standpoint, I mean. And then another thing is reducing usage of Booleans as much as possible, because a lot of times Booleans can be really expensive. A lot of times Booleans will use like a full slot because how it's stored. Like it'll store it this or 0. And so you can store it as bytes. Or just, it sort of depends on like the scenario, but in hack them.
Well, how do I convert from bytes to Boolean?
So let's say we have a struct that has full correct let there. This is admin full and play. Anything. So I haven't used it. It is kind of rare to have to pack Booleans, but in this case, they way out fixed. It is kind of rare sometimes to have to pack Booleans because Booleans straight up aren't as common. But ChatGPT comes in, they pack
By the way, do you know any on-chain databases that are gas efficient?
On-chain databases?
Yes. So I'm looking at mods like the gaming framework, and they have their store. I can send you right now.
Sure. Oh. Let's see.
Now we have databases of it on chain. Expensive, bro.
Yes. Yeah. It is kind of interesting though. I'll have to look into this. For some reason, I've been liking the version. Kind of off topic. I've been liking earlier versions of Solidity. Have to worry about so much overhead.
Nice.
So this seems to be a little bit game related. That's why I thought.
Okay. Yeah. I think, yeah, it is expensive, but this is definitely something that is oriented towards layer 2 for sure. Roll-ups.
I mean, it says I haven't compared any benchmarks, but in some cases it's more efficient than Solidity, it says.
Really?
Yeah, so if you scroll a little bit down, finally, stores code up. Finally, stores gas efficiency, the uppermost paragraph. Yeah.
Oh. Okay. Setter and getters. That's cool. Wait, is this? Oh, okay.
This is for building autonomous worlds, online on-chain games.
That's really cool. Yeah, it makes it a lot simpler. Cool. I'll take whatever you or on-chain. If it's quick enough for that, then really more efficient for others.
Yeah, not for every use case, but I mean for games, to store everything on mapping will be like very hard to track, etc.
Maybe they use a Merkle tree to make this cheaper.
Oh yeah, probably. Yeah.
How do we unpack? I want to know how do we unpack the booleans. Can we go back?
Oh yeah. Sure. So I had done this, but you're not actually storing a boolean, but you're storing it as another back in it. And then so this returns the win count. So the bitwise operator, you're returning the second bit. You're shifting it 2 to the left. And then so this isn't the most efficient because you're still using events, but it's just way cheaper to access, just like, because you only need 1 bit for a boolean. So using like a full slot for a boolean is just extremely expensive. You have like really don't need to. You have two bools.
It's not a bit mask, right?
Or bit mask. Yeah, it is.
Yes. Okay.
Yes. So you see two booleans stacked next to each other, just know that there's room for improvement, and it may sort of be monotonous, but yeah, using bit masks, there is further improvement. Like, the first thing that I always look at when I look at a new contract is the structs. Like, if I'm coming at it from a gas perspective, looking at structs, I'm looking at for loops, and I'm looking at storage variables. Those are the three biggest things to take note of, because a lot, see, like, yeah, for loop, boom, storage variable, boom, like, that's just where you're going to get most of your finding. And then there was another Code Arena contest that Angle Protocol. Take me to it. Oh dang, it's already been. But yeah, there's so much resources on gas. Like Solady. Like, if you haven't already, follow Vectorized on Twitter.
The optimizer.
Yeah. Like, all of his projects are great. Same with hair. Like, GasLite project. Really cool. Efficient airdropping. But these guys are, I mean, they don't really as much anymore drop alpha, but it's all like projects that are really cool, and they share a lot of gas related projects. And another thing is Huff. Like, if you haven't taken a look at Huff, if you're someone who likes contributing to these types of projects, Huff is really and it's obviously got a growing community. It can help you understand opcodes and lower level programming for the EVM a lot better because of the syntax. And yeah, it's really cool if you like dealing with like sort of experimental stuff. You're not going to see it, or like, it's not really a moneymaker. There's not people hiring Huff devs or Huff reviewers, which is kind of like cool low level project that I like to.
Bro, I mean, just from talking to you here and seeing this presentation, and looks, I mean, it's obvious that you have a lot of knowledge. What do you think? Because gas optimization, from talking to the optimizer, a lot of what he does is converting old stuff from other languages. So he needs to come up with a new hashing algorithm or a way to concat strings using bytes. He goes into a C implementation and looks at how the OGs did it, What was the turning point for you that made you understand this deeper level of the EVM?
More when I became more like security minded and switching more from being a developer to like wanting to understand just out of just like curiosity. And I don't know, I just think it's really cool. Making stuff quick is really interesting, and there's just so much bloat. Like, if you could look at a contract, I don't know if there's any tools existing, but if you could take a contract or you just take a look at like Remix, taking a look at like just the transaction flow of like a function call, it's just so bloated. Like, it's just really cool to just like sort of break it down. And when you have knowledge of all the opcodes, it's, I don't know.
Do you think a lot of these improvements will be done at the in the compiler at some point?
That I'm not too sure, because a lot of this stuff is gonna stay the way it is, because like, let's say for example, like storing string as a byte, like there's the string type on chain, and switching it 2 bytes is just like, it's sort of something that you have to explicitly say.
One question.
That's inferred.
Yeah. Yeah, the one question there, that's actually be a dumb question, right? But so everything is deterministic, right? Could be the case that I cannot optimize a string because part of the transaction, the whole transaction must be done. So I need to deploy the contract first. And because of the address of the contract, the outcome of the string will come, or I can simulate the whole way through. Sorry.
Explain it in another way.
Yeah, I think it's a dumb question. I mean, the signature will always be the same, right? Yeah, that's pretty much it. There's no influence on the signature from the smart contract address.
Oh, I think I see what you're saying.
Because it should be easy for the compiler to convert string into bytes, right?
Yeah. Yeah, no, I mean, there's definitely a lot of work that still needs to be done with the Solady compiler. Like, there's just some stuff that just like, I shouldn't have to interfere. And I know that the people working on the Solady compiler know this. But like basic read, like this, I do see it in the future. Not be very like,
bro, these things never change, the quirks of a language, they always keep alive. That's an incredible thing in it. Yeah, I want to open for question, guys. I will be everybody on the mic and people in the chat, please. Haruxi, I don't know how much time you still have, but Haley said, I see you here. Let me invite you to speak. Let me invite actually everybody to speak. How's it going, brother? So yeah, anybody has questions? Let me see the chat here.
What?
Everybody understood everything, man. You're too good at that. I'm telling you. You need to start your YouTube channel, man,
I know.
I guess I actually have a question, and it's related to security. For me, auditing these things is a little bit hard. I guess for everybody, right? Recently, Cantina did the Solady audit, which OpenSense also worked a little bit with Chung from KebabSec on it. And it seems that not every auditor is at that level. And when you talk to auditors, usually they don't care about assembly. They see it more as an MEV thing, heavy optimization as a trade-off, and they trust the optimizer too much. Just want to use Solady, and they don't want to see if there's a mistake in there. Do you think we're going to have more enabled auditors? People will dive more and more into gas now that we have GasLite and this whole narrative being born?
I hope so. But I think the narrative is starting, like, I do agree with you. Most of the people are going to be looking at just like bare Solidity code. And when people are like in a security mindset, yeah, that's something that they're going to fight for. But I think talking to some of the people running protocols, it's becoming more of something that needs to come in your toolbox. And I think that just security reviews in themselves are becoming almost obsolete. Like people who perform like solo audits, like, yeah, so you do get a lot more input from these top auditors other than just security reviews. So you're getting obviously the extensive security review, but you're also getting the guest report, and then as well as sort of like input on UX and sort of the design of the protocol. But I think that's something that we'll see more of, because protocols are starting to value people who contribute a bit more than security reviews, because it is getting very expensive, and because also the standards are getting higher because there are so many people who are starting to get to that level. Yeah.
And yeah, bro. I mean, amazing talk. I don't know if people have more questions. You have anything else to say?
I'm just surprised I had enough to talk about.
And that was really insightful.
Yeah, there's just, like, if you haven't taken a look already at Solady, just every single one of these contracts is pretty much, you can apply. You can just look at like ERC 721. You can just look at it, and it's just so well thought out, and it's just like, just be aware of these things. It's all like bare metal. Follow these guys on Twitter, Harrison and Vector, and also
We follow you too, right?
yeah. Follow me.
Open your Twitter there, bro.
Arooks East on Twitter. If follow, I'd like to shitpost or also give some good tips. Like, I like to spread misinformation about gas optimizations like this. It's
very cool.
Trying to find there's someone in the Jay Trilly. Follow Jay Trilly too.
Legend.
I know I don't know if he like spoke or did an AMA or something.
Yeah, we have video, we have EMAs. I mean, dude is a legend.
Yeah, because of baseball.
Awesome. So, bro, thank you so much. Again, this was an amazing talk. I'm pretty sure that this will be a success on YouTube. And talk to you guys later, okay? Bye-bye.
Yeah, thank you.
Thank you. Bye-bye.